Hi listeners, Benjamin here. Welcome to the Friday Briefing Show, where we talk about a couple of stories we've read about in the Nature Briefing. And it's me and Nick this week. Nick Petrich, how are you doing?
I'm doing well, Ben. How's it going for you?
It's going A-OK. I've got a story I am excited to talk about today, so I'll go first if you'll let me. And you know that I love anything related to Stonehenge or other massive Neolithic site. Anything henge or henge adjacent, let's be honest.
Anything henge or henge adjacent, it has come up many times in our chat. So what's the new henge news this week?
Well, this is a story I read about on the BBC Science Focus website, based on a Journal of Quaternary Science paper, and it's a continuation of a story that was published a couple of years ago in Nature about Stonehenge, and it was covered on the podcast, and it was covered by you, Nick, and it was all about the altar stone. Do you remember this one?
I do remember the altar stone. This was a paper where people were trying to trace the origins of the altar stone, the big central stone at Stonehenge, and they suggested that it'd come from the Orcadian Basin, which is this part of northern Scotland and the Orkney Islands.
Absolutely right. So a lot of Stonehenge is believed to have come from Wales to the west, about 150 miles, maybe 250 kilometres from where these stones are now standing. But yeah, you're right. This altar stone, which is partially buried by another bit of rock, came from maybe 500 miles, maybe 750 kilometres away. And at the time, a question that you and I and a lot of the news team had, and I think the researchers themselves had, is how on earth did the people who made Stonehenge take this enormous 6-ton, 16 feet long, 5 metre long bit of rock from the far north of Scotland to the south of England? Now, you and I both know this is a difficult journey, right? There's mountains, there's hills, there's a lot of woodland at the time. This isn't just a simple straight shot.
No, it's not a straight shot at all, and that's why when I spoke to the researchers on that paper you mentioned, they suggested that perhaps it had come by boat. Is that what people have found, or have they found some other alternative route?
They have found another alternative route, but it is based on water. Frozen water, specifically, Nick. It may be that ice has done a bit of the heavy lifting here to help move this stone to where it is now. So the conclusion that they've come to is that ice flows, so a glacier essentially, may have carried this stone part of the way, at least during Britain's last ice age, which was about 30,000 to maybe 10,000 years ago. But it gets a bit more complicated because the ice didn't do all of the work. It didn't take it all of the way to essentially the Stonehenge site. Previous work suggested that that area of the UK wasn't glaciated at the time. So what this paper suggests is that ice kind of moved this stone not directly south from Scotland to the Stonehenge location, but kind of southeast, and ultimately maybe took it half the distance, depositing it in what's known as Dogger Bank, which was part of this thing called Dogger Land.
This was actually suggested to me by a researcher at the time that could be a possibility, so that's interesting that this analysis seems to support that. But that is only half the way. That's still quite a way to go, and you would have to go from this area still fairly far north of Stonehenge. So how perhaps did people make the rest of the journey with this massive stone? Yeah,
that's a great question. And as is always the case with Stonehenge, there's more mystery to uncover, right? Because Dogger Bank was part of what was known as Dogger Land, this enormous sort of part of land that connected the UK to the rest of Europe. Now, Dogger Land doesn't exist anymore. It is underneath the North Sea, right? At the end of the Ice Age, ice melted, sea levels rose, and this area became inundated. So before that happened, this stone must have been moved from where it was resting to the mainland. And how this happened is a mystery, right? Like, it maybe involved maritime routes. There we are again. It maybe involved what was known as the Berkshire Ridgeway, which is the oldest road in the UK, this kind of Neolithic trail that crosses a lot of the south of the UK. But what is clear is this must have happened, say, before Doggerland ceased to exist. But the timeline here gets weird, Nick, because that happened like 3,000 years before Stonehenge was put together. So a long time before. So this stone was maybe important for a reason. The folk who moved it clearly saw a need to move it. But why? Shrug. I guess lots of different people must have worked together as well. So there must have been some cooperation. So it's this weird situation that we still haven't quite got to the bottom of yet.
Yeah, I'm sure there'll be many more researchers trying to figure this out as well, because it is interesting to speculate as to how people at that time would have moved this massive great stone and also why they would have put that much effort in. So with these open questions, what are researchers looking to do next?
Well, I think at the minute, from what I understand, they're really trying to hone in on where did this stone come from. As you say, it was the very far north of Scotland. Like, could you zoom in to work out exactly where, and maybe the route it took, and maybe even trying to work out more likely where it was dropped before it was rescued from the now no longer existing Doggerland.
Well, I'm sure you'll be here to update us when the next analysis of what happened with this altar stone comes out. But for now, I think we can probably safely move on to my story this week. And this is also looking back in time, but perhaps a little bit further back in time, because this is an analysis of what could possibly be 700,000-year-old coprolites.
Wow, coprolites, obviously fossilized poo. And this makes Stonehenge look like it happened last week, right? Stonehenge is about, 5,000 years ago. 700,000 years ago is way, way back.
Yes, and if that date works out, these coprolites would actually contain some of the oldest mammoth DNA that's yet been discovered. So this was an article I was reading in Nature based on a paper in Nature Communications. And so, as you say, coprolites are fossilized poo, which can be useful for researchers for a whole lot of reasons, but what you may not have been expecting is for fossilized poo from ground squirrels to contain mammoth DNA. And contain it did, along with DNA from bison and big cats and insects and plants and everything. So it seems like these ancient ground squirrels may have been ravenous for all sorts of things that you may not expect.
This is not what I expected you to say at all. Now, I don't know much about ancient ground squirrels living 700,000 years ago. That suggests to me that these animals were preying on all those other things if there's evidence of them in their poo. I can't imagine a ground squirrel taking on a mammoth.
No, so what has likely happened is these ground squirrels have woken up after their winter, not quite hibernation, a state called torpor, but similar. Basically, it's like a winter slumber. They would have awoken and been pretty hungry after months spent in their burrows during the winter and would have eaten basically anything. And that includes the carcasses of these larger animals. As you say, it's probably unlikely that they took down a woolly mammoth, but they may well have found a woolly mammoth corpse and fed on it. And one of the researchers interviewed in this article wasn't necessarily surprised by this because they said they've seen modern day ground squirrels feeding on other ground squirrels, but feeding on carcasses. So it's perhaps not surprising for evolutionary biologists.
Right, but it's kind of this wonderful time machine, I guess, a little window into this area. We've talked about how ancient DNA can give a sense of what animals were present in an area, and I suppose this is doing the same.
Yeah, exactly. So this gives us a window into Canada's Yukon territory. So this is a place where a lot of gold mining is done. And when permafrost deposits are got rid of using jets of water, it can expose these underground burrows and it can expose these coprolites. And as you say, this could be used as essentially like a little archive where you find it. So because these squirrels have been eating whatever it is they've found, we could find like this DNA from all sorts of animals and find it in this region and find potentially really ancient samples. 700,000 years old is a really, really, really old DNA, if that is how old it is. So I must say that this is the suggested date. As is often the case with this sort of dating, it's sometimes difficult to date the sample itself, the coprolites in this case. So they dated some volcanic ash on top of it, and that was found to be 700,000 years old. But if those dates add up, this would be an archive that spreads from 700,000 years ago to 17,000 years ago.
That is quite something. Anything unexpected in the catalogue of animals? We talked about mammoths a few times there, but anything else that I wouldn't necessarily think of?
Yeah, there was also from big cats. They suspect that either North American cheetahs or pumas, so there were big cats in there, bisons, horses, and other megafauna that roamed the region. But there was another surprise as well, which was that originally they thought these samples had come from a type of ground squirrel known as the Arctic ground squirrel, which is Urcitellus parrii, which are similar to the ones that you find in this area now. But actually, they may have come from an unknown lineage that are related to some long-tailed ground squirrels that live in areas of Siberia, Mongolia, China, and Kazakhstan. So perhaps they sort of crossed over to this region. So potentially a new whole lineage of squirrels have been discovered here. And you mentioned the mammoth DNA. The researchers behind this say they've got a paper coming out. There's a forthcoming paper that is just focused on the mammoth sequences. And intriguingly, they say it will reveal further intrigue.
Ooh.
But for now, they're just leaving us with the idea that they hope that researchers could use these coprolites as this archive to find out all sorts of things about animals from this era.
Well, who'd have thought? Ground squirrels hoovering up stuff and depositing evidence in their poo, which has let researchers all this time later figure out what was going on. That's pretty cool.
Yeah, it's pretty cool. I mean, one of the researchers who was interviewed in this article described them as the zombies of the Pleistocene, because you can imagine them emerging from the ground and starting to eat just anything that they find. So sort of like zombies coming back from the dead, although in this case, they're just coming back from torpor.
Well, what a story that is. I think that's a good place to leave it. Listeners, we'll put links to both of those stories in the show notes where you can find out more about them, and where you can sign up to the Nature Briefing to get even more things like this delivered directly to your inbox. But for the time being, I've been Benjamin Thompson.
And I've been Nick Petrichel. Thanks for listening.